Now we'll do another example of a particular special form that will come up a lot in this class. This example has x to the fourth minus 16x squared. Once again, we're going to look for common factors that we could divide out of the coefficients and common powers of x that we could divide out of the exponents. We notice that we have a fourth power in the first term and a second power in the second term. Therefore, we're going to divide both of these times x squared and factor that out. We will divide x to the fourth times x squared and negative 16x squared times x squared. Put the x squared on the outside of a parentheses, and we will subtract the exponents. Fourth power minus second power will give us x to the second power. And then negative 16x to the second power over x to the second power will give us second minus second, which means we will have no x at all. And we'll just write negative 16. The special form that I'm referring to, though, involves any time you have an even power of x minus a perfect square. The special name for this that you may hear in class is called a difference of squares. Difference means subtraction, and squares mean that both the x and the constant are both perfect square numbers. Keep an eye out in this class for perfect square numbers. The most common ones that could come up in this class are 4, 9, 16, 25, 36, 49, and 64. Those are your smallest perfect squares. When you have a difference of squares, we can split that x squared minus 16 into two parentheses. Those two parentheses will look like this. Our first parentheses will be x plus square root 16, and the other parentheses will be x minus square root of 16. The x squared that was outside is still there. But now we must remember that square root of 16 is the same thing as 4. So now our factored form is x squared times x plus 4, x minus 4. Anytime you have a square root that condenses down to an integer number, like 4, you can use this formula. However, if your number is not a perfect square and you try to use this, you can get some really nasty decimal numbers, so don't try to use it in those cases. Use it only on perfect squares. There's another variation on this formula that you can use for perfect cubes. That is, any x power that is divisible by 3 and any perfect cube. There aren't that many perfect cubes that you'll have to remember for this class, but the ones that come up the most often are 8, 27, 64, 125, and 216. Notice in the formula that we have here in the upper right, we've written it in the form a to the third power plus b to the third power and a to the third power minus b to the third power. There are two different formulas, and that's going to be based on the sign in the middle. We want to pick a formula that matches the sign in the middle. For that reason, we'll be using the second form of the formula, that is a to the third minus b to the third. We will say that a cubed is the first term and b cubed is the other term. So we'll say a cubed is equal to x to the third, and then b cubed is equal to 64. After we've written this, we will take the cubed root of both terms. You can also take either one of them to the 1/3 power. That's the same thing as taking the cube root. You may see it written either way. So if we take the cube root of x to the third, that is the same thing as saying x to the third raised to the 1/3 power. Now, anytime that you have a power raised to another power, we will multiply the exponents. Therefore, our new power will be 3 multiplied by 1/3. But 3 multiplied by 1/3 is just first power, or x. Therefore, we'll say a is equal to x. For b, we will take the cube root of 64. If you don't remember this one, you might need to use a calculator. If you do, you'll get an answer of 4. Therefore, we'll say b is equal to 4. Now, we'll refer to the formula for the difference of cubes, which I'm boxing in green now. A minus b times a squared plus ab plus b squared. We'll place the a and the b in their proper positions. For a minus b, we'll have x minus 4 in our first parentheses. Then we'll have a squared, that's x squared. ab, that's the same thing as saying 4x. And then b squared is 4 squared, or 16. Therefore, this is our difference of cubes. Now that we've factored this into a binomial and a trinomial, we could ask ourselves, could we factor that trinomial down any further? In order to do that, we would have to find two numbers that multiply to 16 but add to 4. Let's do some experimentation. We'll take our 16 and think about what we could break it into. 16 times 1 could work. We could also try 8 times 2, or try 4 times 4. But 16 plus 1 would give us 17. 8 plus 2 would give us 10, and 4 plus 4 would give us 8. However, none of the three of those will give us 4x. Since all three of them miss, we can conclude there is no way to factor this any further. Because there is no way to factor that trinomial any further, we're going to stop at this point and consider this completely factored. We'll learn techniques for dealing with this situation much later in the course.